Welcome. Today we'll solve a problem about electric flux through a cube with a point charge at its center. Let's start by visualizing our setup. We have a cube with sides of 4 centimeters, and at its center we have a positive 5 microcoulomb charge. To find the electric flux through each face of the cube, we'll use Gauss's law. Gauss's law states that the total electric flux through a closed surface equals the enclosed charge divided by epsilon naught, the permittivity of free space. Let's plug in our values. We have 5 microcoulombs, or 5 times 10 to the negative 6 coulombs, divided by epsilon naught, which is 8.85 times 10 to the negative 12 farads per meter. When we calculate this, we get a total flux of approximately 5.65 times 10 to the 5th Newton meters squared per coulomb. Now, here's where symmetry becomes important. Because the charge is at the center of the cube, the electric field lines pass through each face equally. Since our cube has 6 identical faces, the total flux will be divided equally among them. Therefore, to find the flux through each face, we simply divide the total flux by 6. This gives us approximately 9.42 times 10 to the 4th Newton meters squared per coulomb through each face of the cube. This result makes intuitive sense because, first, the total flux is positive since we have a positive charge. Second, the flux through each face is equal due to the symmetrical position of the charge. And third, the sum of the flux through all faces equals the total flux predicted by Gauss's law.